All right, so I'm going to do some examples on how to do data manipulation techniques using COVID-19 data. So my first cell in my Jupyter notebook has the libraries and some of the formatting that I would like to have with my plot, which would be this line right here in line 4, and then this line right here, just to make sure that any plot that I have, it will be reflected on the Jupyter notebook without an issue. So I'm going to run that cell and just make sure that it's in memory. So the data is coming from the internet, and I have the link here. So this is COVID-19 data being collected by Johns Hopkins University, and it's made available to everyone for free using the GitHub platform. So I'll be focusing on two data sets, one that is related to the time series in the US that records the confirmed COVID-19 data, and also the COVID-19 cases. And then we also have the time series COVID-19 deaths. I want for the US, not global. But there is global data that we can possibly do analysis on. I'll just click on the confirmed US CSV so we can see how it looks like on GitHub. I'll click on this download button, and we have the CSV data in here. I could download this data and store it somewhere, or I could just copy this URL and do the loading that way. And that's what I have here. So I have the URLs for both the confirmed cases in the US and the deaths for the US. And I'm storing them into their own variables here. So like I said, I could download this into a CSV file and then use a read CSV and put my directory of where that file is on my local computer. But this is just a lot faster without having to worry about figuring out where I want to put that file and then retrieving it that way. So I'm going to run this. And once I run that, I want to do some inspections on these data sets. So I could do the dtypes to get an idea of what kind of columns are involved. So I'll just record that and say dtypes, run that. And this is all of the columns that belongs to that data frame called df underscore cases. I can do the same thing for the deaths. And let me just go ahead and just keep this plural, and I will do the same thing here. Right, so it looks the same. Let me go ahead and do the head method on both of these things. So I'll print out the data frames. I want cases.head, and I want to run that. So this is what it looks like. Now, if I don't use the print statement, the format looks a little bit better this way. It's more readable. So if I'm going to just use one head statement without maybe putting deaths underneath it, then that will work. But if I'm going to have two head statements run right underneath the other one, both of them are not going to be displayed. So I want to make sure that if I am going to have multiple head statements, then I should just separate them out into their different cells if you want it to look like this. So looking at the data, this is a wide structured data set. And it's going to be the same thing for deaths. So let me go ahead and put that in. Right, and that's what deaths look like. So again, going back to the structure, this is a wide data set where we have a bunch of columns where they contain variables, and some columns are not really variables. They're really just values, but they're used as columns just to record data. So everything from UID to longitude that we have here are considered to be variables. And everything after that, which would be the dates. And this is just a summary of what is really in the data frame. But all of these dates are data columns where the recorded COVID-19 cases are present. So in October 10th, there was 1,898 COVID-19 cases in Alabama in this county right here, Atuga or something like that. So this has been going on since we'll see. Actually, we'll do a min function on the dates variable once we convert this into long data. So This is not really good for data analysis because of its structure. So we're going to eventually melt this data. And this is something that we're going to be doing in a little bit. So after this import, we want to go ahead and focus our attention on a particular state rather than a bunch of states. Because right now we're just seeing Alabama, but we have it says 5 rows because we're doing the head method. We have 284 columns wide, and that's not going to work out. That's why we want to convert that into long data. Let's go ahead and just do a shape attribute so we can really get an idea of the shape of this data frame. And I'm just going to go ahead and just focus on the dots data frame and do shape. So there are a total of 3,340 observations, and that is this is going to represent the rows, and there is 284 columns. Okay. All right, so that's a little bit about the data. The df underscore cases is pretty much the same thing. Let me just go ahead and do that. Yep, but there's 283 columns rather than 284. So there's one extra column that the cases data frame has. And we can do a dtypes to see that, right? So this is what we did earlier. It's summarizing this just because there's a whole bunch of columns involved. Okay, so I want to just focus on one state, and then we can narrow it down even further if we want to. So here is the column that contains all the different states in this collection. So it's collecting data on the whole, like 50 states and some. And so let me go ahead and subset. So I am going to create a new variable and call it VA cases. And I will subset the cases and focus on the province state column. And I want Virginia data. All right. I will do the same thing for the other data set that is recording information related to death. So that will be stored in there, and I need to change the data frame where this subset is coming from. So here I need to put cases. Here I would need to put deaths, and that should be good. So let me go ahead and run this. So now I have the subset. I can go ahead and create another cell and just do a head method on either one of them. So I'll just use cases just to see how it looks like. Yeah, it's good. So here we have a data frame now called dfva cases that's just storing information related to Virginia for cases, and then here's one for deaths. All right, so we have our subset. Now there are going to be columns in here that I don't really need to use for my analysis and I want to remove. So I could use the drop method, and this is a Pandas method. So the way that this would work is you would first indicate which data frame that you want to drop columns on, and then you would use the .drop method and then open up parentheses. And in the first argument is going to be a list of the column names that you want to drop. So the ones that I want to drop here are going to be columns such as UID, ISO 2, ISO 3, code 3, and so on. All this is redundant information. It could slow some of the processing when I do the analysis, and it's really just not needed for what I want to do. So I would put all of this information in a list as a string value. So each column name will have quotes between them. So it can be single quotes or double quotes. So I'll go ahead and just do double quotes, and I don't need long. So I have to make sure that I spell them exactly the way that they're spelled out. It's case sensitive, so that's something that you have to be careful with. So yeah, that will be all of them that I would want to remove. And I'm doing this for the cases, the Virginia cases data frame right now. And there's going to be another argument that I want to indicate here. So we do have the labels, which I'm including here, and we have axes. So right now this says 0, and I want to change that to 1. So by doing this, I'm indicating to the method that I want to drop the columns, and so I want to say equals 1. Equals 0 means I want to drop certain rows, so I'd have to indicate the row labels and drop them that way. Now there is an in-place parameter on this function, and I'm going to set that to true. By default, it's always false. So that means that the dropping of these columns are going to be permanent on this data frame. I don't really need to assign it to a new variable that will store that change. So I will go ahead and run this and see what the error is. So it says that that there's a value trying to be set on a copy of a slice from a data frame. So if you recall that df_va_cases is a subset from the df_cases, and that was shown here, right? So when I did the subset, I didn't use the copy method. I didn't chain that into my subset. So this is why I get this error, and I get this warning error. So the change will reflect, but I'm getting a warning message. And if I don't want this warning message, when I subset, I would chain the copy method, and then it creates a brand new copy of a data frame rather than a reference copy of the original data frame. So by doing this, and then now if I were to run this, I won't get that type of error. So let me see if I can run it. All right, so it ran just fine without a problem. Now, if I were to try to run it again, I get an error. And that's because the data frame already dropped the columns. So that's one thing that you need to be careful of. If you're trying to write multiple lines of code, and let's say this was the first line of code that you started and you executed just to see if it worked, and then underneath it you're trying to maybe write some other lines of code and then try to run it, you're going to encounter this infinite error, just because this is something that you can only run once. All right. So the only way that you could run this again is if you reset this data frame and it has its original columns in it. So again, if I were to run this previous one where it creates a subset, go back here, that means in memory it has all the original columns in it. If I run this again, it's going to run successfully, right? But if I try to run it again right now, it'll give me an error. So if I'm trying to do the same thing with the data frame related to deaths, I would want to make this, I would want to put that line of code in another cell. So I will just change that information here. And these are the same columns that I would want to drop in that data set, because that data set has very similar columns, with the exception of maybe one column, I think, in the cases that has the population data column. And it went ahead and ran that. So I will go ahead and run a head method on cases just so you can see how it looks like. All right. So it's a lot cleaner. Now we just have just a few main data columns. And then these are the columns that are related to that wide structure that we're eventually going to reshape and make a dates column and store all of the dates as rows. And then we'll also store all of the reported cases as rows as well. And that's what we'll be doing in a little bit. All right, so the goal is to try to convert this from wide data to long data. All right, so we took care of the dropping of the columns that we don't need. Let's go ahead and talk about how to reshape the data frames. So to melt the data or reshape the data, you would use the melt function. So the melt function is a Pandas function. So I would say pd.melt and then open up parentheses and then start indicating the information that I would need to include in this function. Here are all the different types of parameters that this function has, and I'm going to be using some of them, not all of them. And I could scroll down to get more information and examples, or I can go to the website or internet search and type in the function and see what kind of information is provided that way. So I will go ahead and indicate the ID underscore vars. So this part of the function is the different columns that you want to keep as is. All right. So, but before I indicate the ID underscore vars, I need to put in the data frame that I want to melt first, and then I'll indicate ID underscore vars and value vars and var name, as well as value name. So the data frame that I want to make the change in is the Virginia cases. So that's the data frame. And then now I will do the keyword arguments, and I'll say ID underscore vars. And as a list, I will put the name of the columns that I want to keep as is. So the ones that I'm going to keep as is are everything from admin2 to combined key. I don't want these to pivot or change or reshape. But what I do want to reshape are all the dates is as one column. So I will need to include all the column names as a list. So I have admin2 key. All right. So that the ID underscore vars are all of the IDs or all the columns that I'm going to keep as is and not reshape. Now, the next one has to deal with the var name. So when I'm melting the data, I need to give it a name. And that's going to be another parameter. So after the list, I hit comma. I'm going to hit enter so I can include all my code within the cell without having to scroll horizontally. So the var name is going to be, we'll call that dates. So it's going to have a new variable name called dates. And the next parameter is going to be the value name. And the value name is going to be another column label that's going to contain the associated COVID-19 reported case for that date. And I will go ahead and just call that, in quotes, cases, right? So all of these things are as string values. Now, I'm going to assign this all into a different data set, and I'll call this VA cases melt. So this is going to be a new data frame that's going to store this information. There's no in place parameter here, so I will need to store this into a new variable. I will go ahead and run this, and it executed just fine. Okay, so I'm going to do the same thing, but for the deaths data frame. So I'm going to copy this information over that I did for the confirmed cases and just rename some things. So I'm renaming where it's going to be stored and the data frame where I'm going to be melting that's related to deaths. Now, this data frame contains, it does contain an extra column that I want to keep. And I know this based off of my investigation. So I want to keep the population data column. So I am going to include in here population. I don't want it to reshape. So it's population. All right. And I will hit enter and put it right there. And I will rename the column to deaths. All right. So let me go ahead and run this. Okay, after I ran this last data frame where it melts the data, I went ahead and did two head methods on the two data frames. So one that's related to VA cases melt, the other one that's related to VA death melt. And this is how it looks like. So we have in cases, we have the cases related data, but in the deaths, we have the deaths data, but we also have population that's different from the cases data frame. So what we want to do is we want to combine both of these data sets. Since they have common columns and common rows, we can go ahead and merge them or join them together. And I'm going to be using the merge function. So the merge function is Pandas function. So you use pd.merge, and then in there you would indicate what you would want to put in the parameters. So I'll go ahead and expand this. There are a bunch of parameters. So I'm going to use the VA cases, or which one has, yeah, let's go ahead and do the VA cases melt and VA death melts. Right, so these are two data frames that I want to merge together. And then from there, I am going to say how I want them to be merged. So I'll use a keyword argument. I'm going to say how equals left merge. So I'm basically saying that the common keys that we have between them, I want them to be merged together. So the first data frame, which would be on the left, is the cases, and then the right would be that. So we're merging this to the left into the cases. So that's why we have left. So it would work on different types of arguments passed into the how, but I'm going to be choosing the left. And what we'll see eventually is that in addition to cases, we're going to have the population added as well as the deaths added into the data frame. So now that's the how parameter. I now want to say on which common keys do we want to match up. So I can say admin2, and this is going to be as a string. I'll also say the province. Right, so these are the ones that we have in common. I believe we also have dates. So let me also include that. Let me hit enter and put in dates. All right, so that's what we have in common. I'm going to have to assign this into a new variable. So I'll call this dtypes and I'll run it and see what kind of errors and then fix it. So VA cases. Okay, well, I know VA cases is supposed to be VA cases underscore melt. And this is supposed to be underscore melt. There we go. So I will do a head method and see how it looks like on this variable. So I'll say head. And now we have the merged data frame. We have cases, we have population, we have that's all within one data frame. All right, so if I'm going to be referencing some of these columns, I want to be able to reference them easy without having to remember some of the names, the original column labels. So I am going to use the rename method, and this is through the Pandas library. And I am going to make a change on some columns, not all of them. Particularly, I want to change admin2 and change that to the label called, I'll call it county. I'll also change the province state, and I'm just going to call that state. And the way that this works inside this function, we have a bunch of parameters. So the mapper is going to be the dictionary-like format that I'm going to put in as the first argument. And then I will use the in-place, let's see if it's here. Yeah, I'll use the in-place parameter to make sure that the change is permanent within this data frame. So for the mapper, let me just go ahead and take care of that now. And that's going to be, well, actually, it's kind of a combination of columns and mapper, where I'm going to indicate the columns parameter, and then I will map the column labels to what I want to have as a new column label, right? So I open up curly brackets. This indicates it's going to be a dictionary. The key is the original name of the column. So that's admin2. And the value that's mapped to it is going to be the new name for that column. So I'll call that county. And I want to make another change. I want to change the province state. And I want to call that state all in lowercase. And then I want to make this change permanent. So I'll say in place true, right? And when I'm executing this in this cell, I also want to do a dtype to see the change, all right? So let me go ahead and run this. And here are the dtypes. So now my column names have changed. I do have county, I do have state. I no longer have the admin2 or the province state. So it's easier to reference when I'm coding.
Okay, so after renaming some of the columns in the dfva merge data frame, I want to filter some of this out, some of the data out. And I'm going to use the query method to filter. Before I use the query method, let's just take a look at the first 5 rows of this data frame. And paying attention to the cases column, we have a bunch of zeros. And that's because the first recorded date in this data set is January 22nd, which is is day 0 for the United States, meaning that's the first day that the outbreak of COVID-19 happened. And so that's day 0 for the United States altogether. But if I want to figure out what day 0 is for Virginia, I would need to figure out when was that very first case or first couple of cases if it happened on that particular day. So what I'll do is filter the data out and say cases is greater than 0. And then from there, it'll show me what that first date is. And I'll go ahead and use the query method, and I'll hit Shift Tab. And when I do that, I'll get the documentation. And the documentation says that it needs an expression. It also has it in place, so I don't need to assign this information to a new variable. And it can take other keyword arguments. And the way that this works, the expression in particular, it accepts a string. So the way that I'm going to write this in is I'll indicate cases inside a string and say greater than 0. Okay, and my data is already Virginia, so I don't really need to filter out anything in state because I already did that earlier. So I'm going to also say in place equal to true, so we can just make this change and only reflect the cases that are greater than 0 in this data set. So I'll go ahead and do a df va merge head so we can take a look at the results. Run it, and there we have the first record is our first record of where we discovered COVID-19 cases is on March 8th. Okay. Now what we see here are the column indexes, and so these are not going to change. We could reset them and we can start at 0 if we want to. There really isn't a need right now, so I'm just going to leave the column index numbers as is. Okay, so now we have an idea of what date day 0 is, and that's March 8th for Virginia. Now I'm going to be doing some calculations to the date, and if I check the dtypes, looking at the date in particular, it's an object. So remember, dtypes is an attribute where it gives us a list of the columns and what kind of data types that's being involved. There's also the singular, which is dtype, and it's for a specific column. So if I want to check the dates and use dtype, it will let me know exactly what type that is. O is for object. Now I need to change the data type for dates. Okay, I'm going to be using the dot notation. It's just faster than having to use the bracket notation and then saying dates. So I'm just going to stick with the dot notation, say that. And to change it to a datetime object, I know this is a pandas function, so I'm saying pd first. If I didn't write the alias pd earlier when I was importing pandas, I would have to write the entire pandas word out. So I don't want to do that. I'm using the alias. And I'm going to say to datetime, and then I'll go ahead and write merge dates. All right. And I do want to just double check this when it runs. Okay, typo, I'm sure. Oh, yep. Let's see. To datetime. Yep. Let me correct that. Okay, good. So now it's a dtype where it is a datetime. So this is the value that represents a datetime. Now to calculate the number of days into the outbreak for Virginia, what you'll do is you'll have to look at the minimum date, and we know what the minimum date is now based off of what we did here, and that's March 8th. Okay, and what I'll do is use the min method on dates, since I did change the data type, and it will let me know what the minimum date is in my data frame, right, that I filtered out. So I know what the minimum date is. I'm going to be subtracting the dates column. So the dates column here, I'm subtracting each one of these dates from the minimum date, and it's going to give me a result. Now, this is a form of broadcasting. There's no iteration, but once I do this, it's going to do it for every single. It's going to do it for every single record, right? So it'll iterate on every single record by itself and give me the result. Now, I need to put this in a new column within this data frame. So the way that I'll do this is I'll just copy that data frame name, and I will, in square brackets, I'll say VA outbreak. Okay. And once that runs, I want to see the first 5 rows. And run that. So here's the result. We have a new column. Here's day 0, the first outbreak in Virginia, and then 1, 2, and etc. So we have multiple 2s because we're looking at different counties. All right, so what I'm going to do is subset data using the isin method, and I just want Fairfax County data from this data frame here. That's called the dtypes. And it's a pretty simple method to use. And let me just go ahead and create this new data frame called df Fairfax. And I will use this data frame to do the subsetting. I'm going to have to put this in square brackets. And I will, in square brackets, put the county, because I'm going to be extracting information from the county. And I'll put it isin and open up the parentheses. I'll hit Shift Tab when I'm in the parentheses for that method to see what the documentation looks like. So here we would put in the values, and the docstring, which is just the documentation related to that method, says it will, whether each element in the data frame is contained in values. Okay, so here is values, and I'm going to have just one value, and it's going to be Fairfax. All right, so exactly spelled the way that's inside the counties data column. If I wanted additional column or additional values or additional counties, I would just put them in and separate them by a comma. So if I wanted Arlington, I would go ahead and put that in there. But I just want Fairfax. And I want to do a head method once I run this so I can see how the data looks like. All right. Let me go ahead and run it. And looking at the county column, it's all Fairfax related data. So that's exactly what I want. Okay, so using the def method, what I'll do is create a derived column, meaning I'm going to use the data that's in here in this data frame and create new data. And before I do that, I just want to explain this, the cases data column, where each record, each observation that we see in cases represents the total number of cases reported up to that particular date of COVID-19. So what I want is to calculate the new cases reported for that day, not the total cases up to that date. So the way that this would work is using the diff function or the diff method, but we could also do this manually using a for statement. And it's going to take a lot more code, but this is the beauty behind methods. It takes care of a lot of the coding for you. So I will be using the Fairfax data frame, and I'm going to create a new column. So I'll say new cases right here, and I need to put this in quotes. And now the way that this is going to work is I'll focus on the column that I want to take the difference method on. So it's going to be the Fairfax cases. So if I use dot notation, I'll just write it like this. And then the method is diff, like so. All right. So what it's going to do, it's going to look at time 1 and time 2 and subtract the difference, and then put that number in the time 2 record. So it's going to add a new column right next to the VA underscore outbreak, and it's going to do this for every single one of these columns, right? So then it'll go off to the next set. So it'll look at time 2, time 3, subtract them, put that information into the time 3 record, and so on. So I will also want to use the head method just to make sure that it worked out okay. Let me go ahead and run this. And it has to deal with the slice copy, right? So when I created my subset earlier, I didn't use the copy I didn't attach or chain a copy method to it. So the change is there, and you can see that column right here. So to avoid this type of warning, you would want to make sure that you put a copy method when you filter out your data. So I could just run this again, no problem, and then I'll just run this again, and then I won't have that error. Okay, so now I have the new cases column, and it's calculating the difference between time 1 and time 2 for all of my records. The first record is NaN, which stands for not a number. It's a null type of value. So normally if we had many of these and we're trying to do analysis on them, we'd have to figure out a way to get rid of them. There are methods to do that, and there are methodologies that you would want to look into depending on what kind of analysis that you're trying to do. Sometimes you fill them in using the average, or fill them in based off of a particular value. It's not really going to have an impact on what we're trying to do right now, so I'm going to leave it as is and demonstrate how to calculate another derived column, and this is the percent change. So we'll do that next. Okay, so next I want to calculate the percent change of the total cases per day. And what I did earlier is I calculated a difference of the total cases for every record, and I have a new cases column that shows this. So on, let's see, March 10th, there was 1 new case, and in March 12th, there was 2 new cases, and so on, where the cases column, it just shows the total amount, so it's a cumulative amount. Now I'm going to do percent change method, and it's the way that this works is very similar to the def method, and I'm just going to copy and paste some of this and leave everything as is except for this method. This method will be percent change like this, and that's pretty much it. I'll just go ahead and create a line saying that I want the first 5 rows, run that, and scroll over to the right, and there we have it, right? So here we're getting a percent change of the total, and it's calculated for every single record. And just like with the new cases, the first record represents not a number, which is null, but then there are values for every single one of them here. So I could do the same thing and calculate the percent change of new cases. Well, it'll just pay attention to this column right here, and the same thing would happen. It would just broadcast on all of the records in the data set.